Hi everyone, today I show how to use PWM on NuttX. PWM stands for Pulse Width Modulation. Basically you have a periodic pulse when you control the width of this pulse. PWM can be used to many applications, from motor speed control to light dimming, photovoltaic battery charger, protocol communications, audio signal generators, and many other applications. We'll use the PB0 pin in the timer tree channel tree to generate this pulse. Open the CodeBlocks IDE to show you how to use the PWM configuration. Open the previous project. In headers, config, STM32 F103 minimal. Open the STM32 F100 minimal.8. We need to define a PWM timer equal 3 and a PWM channel equal 3. Now I'll show how to use these definitions in the source code. So inside source, config STM32 F103 minimal src and 32 pwm.c. Go to top of this file. We need to double check if config PWM is defined. Config STM32 timer tree is defined, and timer tree is defined to use as PWM, and timer tree channel is defined to use the PWM channel we want for this application. We need to pass the STM to PWM initializer, the PWM timer we want to use, and so basically that is it. Now we can compile the NuttX source code, enter inside NuttX space, inside NuttX, execute make dist clean to clear previous configuration. Okay, now enter inside tools, execute configure STM32 F103 minimal PWM config. Okay, now execute make menu config to double check if all definitions are there. In system type, go to STM32 peripherals support, double check timer tree is enabled. Now in timer configuration, double check timer tree PWM is enabled and timer tree PWM output channel is defined to 3. Okay, now go to device drivers and double check PWM driver support is enabled. Okay. Go to applications, configurations, examples, verify if the PWM device path is correct. Okay, frequency and durations, okay. Now we can run make to compile the source code. Okay, let's speed up the video again to finish the compilation fast. Now we need to flash this NuttX.bin inside the board. We use the OpenOCD to do that. So we need to run this long command line. Okay, it was flashed. Now we can run minicom, reset the board. See, the PWM command is there, we need to execute it. So I will show the signal on oscilloscope. We can run the command. So this is the PWM signal generated by this board. In the next video, I'll show how to use this PWM for a practical application. Thank you very much. See you in the next video.